We have a problem here.
Nobody likes to get bridged.
There's a term?
Yeah, there's a term, getting bridged.
You don't want to get bridged.
With knowledge comes power.
What are we going to do with this power? We're going to build a tiny bridge.
We're Tamar Lab, a tech innovation studio based in New York City.
Since 2010, we've helped startups and global brands turn bold ideas into real hardware that people actually use.
And this is Potentially Genius,
A series created in partnership with DigiKey.
What if your office could warn you before you get stuck in bridge traffic? Can a low-cost Arduino predict that a drawbridge will open? Can a camera actually learn what a bridge looks like? These questions and more have been asked by way too many people. We're going to answer these questions on Potentially Genius with the Arduino UNO Q.
Andrea, could you introduce yourself?
I'm Andrea Riquetta, and I'm Principal Product Evangelist at Arduino and Senior Product Manager at Qualcomm Europe.
So you brought us the Arduino UNO Q. Can you tell us more about some of its standout features?
Compared to the standard Arduino boards with a single microcontroller, the microcontroller sits in a board with a microprocessor.
So that means you're running Linux and Zephyr side by side?
The STM can handle real-time motor control, reading input sensors, but on the other side, install, for example, all the standard packets that are used to work in Linux. If you can imagine how this can work together, this is really a game changer.
With all of these capabilities between the two processors, we're thinking like what could be something that lives in the world that is now just extra smart. Some of the ideas we've been kicking around, observing phenomena and trying to make decisions about it, making very quick decisions like a sorting machine.
Even ideas like a Rubik's Cube solver. We're going to put our thinking cap on and decide a good one here.
Andrea, thank you so much for bringing us the Arduino UNO Q. We are so excited to see what we can do with these two processors working together.
I cannot wait. I'll be here waiting for you.
We are in Greenpoint, Brooklyn, and Greenpoint, Brooklyn has a very famous bridge. It's the Pulaski Bridge. Most of our employees walk over the Pulaski Bridge to get to work. And as drawbridges do sometimes, it goes up. And we need to know when it's up so that we're not late to work.
Exactly.
So this is like a traditional Arduino. It can do Arduino things, but it also has
a Qualcomm Dragonwing MPU.
Amazing. That just makes this go from being a project board that can do things like control servos to something that can now do full AI ML inferencing.
Another great thing about the UNO Q is it comes with Arduino's new App Lab. So this is a really easy way to actually integrate your Python code. It comes with all these pre-made examples and bricks. It makes it really simple to get started.
We figured we could use this brilliant board here. We can hook up a webcam to it. We don't even need to use a MIPI connector. We can just plug in a traditional webcam and we can start looking at that bridge using the Qualcomm Dragonwing, training that model, demonstrating its confidence level and whether it knows whether the bridge is up or down. And then eventually I think that'll lead into prediction models so that we can actually predict whether the bridge is going to be up or down. We want some kind of display in the office for when you're going to leave to know whether the bridge is up or down. For that reason, we're going to build a tiny bridge. So we're training this model on whether the bridge is up or down, and it's going to be able to give us a confidence on whether it has an up bridge or a down bridge.
Right.
And all of that prediction, all of that inferencing is happening on here, right? We're not doing this in the cloud.
It's not just looking at one pixel to see if it's red like the bridge or blue like the sky, but we're actually able to detect features of the bridge. And that allows us to detect the state of the bridge in all kinds of weather conditions, in all kinds of times of day.
With this being sufficiently trained, we could distribute this to other people with other bridges and they could just drop it there. And so now all the drawbridges of the world, we can know if they're up or down.
With knowledge comes power.
Yeah, what are we gonna do with this power? We're here outside our office on the Newtown Creek. We got boats going by and they go under the Pulaski Bridge. And we want to make sure that our mini model is as faithful to the Pulaski Bridge as possible without making it like an exact replica. So I think we should pick out, kind of like a caricature, the features of the bridge that we want to include.
I'm definitely thinking the red color. I feel like it'd be super cool if we incorporated that.
Yeah, I think we can get that exact red too, because it's like rust, but it's more beautiful. I am a big fan of this trellis shape. It's like got this really signature like
look.
Yeah, for sure. And then also the lighthouse. It'd be really cool if I could make that light up or definitely include some of its architecture.
Yeah, I think that would be really beautiful. All right, I think we have a plan.
Yeah.
Let's talk about the elements of this project. The core of it, of course, is going to be our Arduino UNO Q. But we're going to need other things to make this work. So
Right.
we need to be able to see the bridge webcam.
USB webcam.
Okay,
Yep.
which we're going to source from DigiKey. We've chosen this model here. Power supply wise,
So this just runs off of USB-C.
we're going to need to source a dongle like this one. From a mechanical standpoint, we're going to put this guy inside, and we're going to put a camera outside, and then we'll create a housing that can go from in to out and a little gimbal type thing so we can point the camera. For people who can't walk over there to the window and look at it, we have a big shop over there. Let's create a second tiny bridge. And because this is already Wi-Fi networked, we'll just use another one of these and attach it to a couple servos
Yeah.
to control a tiny bridge. Servos such as these.
So Lucia, I see you have an enclosure built here for the UNO Q.
We really wanted the camera to live outside the window so that we could see the bridge to our best abilities. So I designed a waterproof housing that uses gaskets around the front and the cord in the back, the UNO Q, with the Charlie Pucks display and a clear housing to show it off. We also made it so it can pivot both up and down and to the side so you could capture the bridge at any angles.
Awesome, so we can perfectly get the bridge in frame. All right, so tell us about this model. I'm really excited to learn about this.
I built a scale model of the bridge. So this has servo motors inside that move the bridge up and down,
Oh, wow.
reading from when the real bridge is up and down. And then we used another UNO Q in the bottom to control this.
All right, Lucia, what are the next steps for assembling this and getting it working?
Okay, so we're just gonna hook up our wires to our UNO Q below, upload some code for the LEDs and the servos, and then screw everything together and it will be ready to go.
Cool.
So now that we got the camera set up outside, how are you using it to train the model?
I basically ran a time lapse on the camera. It would take a picture every 10 seconds. And I ran it for like a week or two. See, 73,792.
Whoa, it's a lot of pictures to sort through. So all these pictures allow the UNO Q to be able to realize if the bridge is up or down?
Exactly. Arduino App Lab is super easy to use. They have all of these example programs. Here we go. I've created this new project that's based on this example code. So we're gonna click Train New AI Model. There are data points that represent the down images and data points that represent the up images. And what we should see is some clustering between what is down and what is up. The more conditions you can see the bridge in, like maybe one day it's foggy, or maybe it's raining, or maybe the sun is coming from a different angle. The more data points you have, the better it's going to work. The model is now running on the device itself.
So I have our scale model finished and let's program it now to make it work.
All right, cool. I want to do some motor control. So we have to figure out what fully up is for this motor and what fully down is for this motor. Now that we have these values, we can slowly interpolate between them in order to get the bridge movement. Yeah, you can see the bridge is up in the preview. Over 70% sure that it's up. Honestly, it's really impressive considering the bridge is such a small
Such a small part of the frame.
Guys, what am I looking at here?
Lucia made this model, I programmed it, and now it is going to reflect the actual state of the bridge. So here's just a demo of what it's gonna look like.
Oh look, the bridge is going up.
Yay!
You nailed the details. We got the lighthouse. I love that.
Yeah, so now we're gonna set it up to match the actual bridge and fine tune the motions a little bit more.
Don't worry.
Oh,
it's
look,
going.
look, the certainty that it's down is really decaying.
Yeah,
Oh, and the certainty that it's up is really going up.
and look at that.
Oh my gosh, it's working.
That's so cool.
We set this up in a very short period of time. It is now able to know when a bridge is up or down. It's able to reflect it on the internet. We're now able to collect data too on up, down events, record video or stills that we can train more data on. But we eventually want to get to predictability. What do we need to do next to get to that place?
Essentially, we'd need to collect a lot more data about when the bridge goes up, how long the bridge goes up for, what time of day, what time of week. And eventually, once we have enough data, we can kind of build a model and say like, hey, it's Wednesday at 4 p.m. and it's kind of likely that a boat might pass by right now. There's a lot we can do now that we have this platform to make it even more usable and make it even more useful for the future.
Mm-hmm. Then you'd be able to know even before you get stuck at the bridge.
Exactly.
Cool.
So Andrea, we have this problem where we work in Brooklyn. We're at the top of Greenpoint, and from our office you can see the Pulaski Bridge. It's a famous bridge. Cars drive over it, but mostly pedestrians and bicyclists drive over it. And the problem is the drawbridge, and it has no set schedule. They don't really design the boat traffic around people's commutes,
Okay.
so you can get bridged, is what we call it, trying to get to the office on time, and it makes people late. We thought we could at least gather some data and let people know when the bridge is going to be up so that they can plan their commute a little bit better.
Well, that's interesting. That's a real problem. I mean, like, being bridged is not a good situation, right? I can understand.
What we're showing here, this is actually a view from our office window. So we sourced this Arduino cam using the Arduino App Lab, giving the percent confidence, whether it's up or down, and we were able to quickly refine it so that it works. Oh, we didn't stop there. After creating this proof of concept, we tried to productize it in some way. The first step was the camera. We created a laser cut and 3D printed housing for it, as well as on the reverse side, it is holding one of the Arduino UNO Qs.
Easily weatherproof, easily powered from something indoors as well. Looking at a scene that's moving all the time with light changing and weather changing, putting it outside, that really improves our capture. And then we didn't stop there, so we took a second Arduino UNO Q. We love that there had the Wi-Fi on it so they could easily talk to each other, and so that controls this miniature bridge model.
Wow, that's super great. So what I really like is the way you have used, all the things around the UnoQ, not only the hardware itself, but also training the model to recognize the bridge. So that's, wow. Congratulations.
Well, thanks, and congrats to Arduino too. I mean, I think that the speed in which we were able to test this, refine it, and stand it up was faster than any other computer system we've used in the past. We were using your person classifier and then adapting it for our needs, and we created this bridge classifier model based on that from the network.
The board from the network, yeah. That's a really clever usage of what Arduino provides. So you don't need to, go away from the platform, I would say. So everything is here. We have the hardware, we have the software, and then this way to use also App Lab and, managing models trained, custom models trained. So that's super great. So it's exactly the way we would like, as Arduino, that people use our board. So that's super great.
Do you think we created something potentially genius?
I would say absolutely yes. That's super great. Congratulations.